I'm Larry O'Brien. I'm a Vice President of Research at ARC. And we're here to talk about integrated process control and safety. And we have a very good group of presenters today. I'm just going to say a few introductory words. If you were here last year, you probably saw the flip side of the coin of what we're going to present today. Last year, we had some presenters who were very much of the mindset that process control systems and safety systems should be separate. But today we're going to talk about some of the advantages of maybe integrating and interfacing those two systems together. And I just have a few slides to start off with. So what we see today is, and there's a very good reason why we keep talking about safety, we do see a trend, maybe not so much in the overall number of incidents, but in the severity of planned incidents. And if you read the news or you read the trade press, I'm sure you're familiar with some of these high-profile incidents that have happened over the past few years. That's why we have a big focus on developing a safety culture today. There's a big focus on that. Obviously, a big focus on safety standards, implementing those standards, and how to deal with the life cycle aspects of those standards, which is also important. The third thing we're going to talk about is the need to modernize the safety system infrastructure. So if you heard Mark earlier in the last presentation, he talked a little bit about control system migration. And I think we've had some other case studies here this week on control system migration. We feel that there's also a challenge in safety system migration, and it's probably a little bit more complex than what we see on the control system side, and obviously more involved and much more tied to the standards that we see today. The other issue I think we may want to talk about today, and keep this in mind as you're planning your questions for the panel later, is the economic value proposition of process safety. You know, many times it's difficult if you're an end user to approach your management and try and articulate a good economic value proposition for process safety. You know, of course, mitigating hazards is always a top priority, and saving human life is the top priority. But, you know, what we found at ARC is that better safety systems also mean improved plant profitability, reduced unplanned downtime, obviously, and reduced operational and maintenance costs. So there are many business benefits that go along with a good process safety strategy as well. And I read a very interesting report recently from this insurance provider called Marsh, and they put out this report that analyzed the 100 largest accidents in the hydrocarbon industry over the past several years. The database goes back to the 70s. But I found some interesting statistics out of this report, and they say that the combined financial loss from the 100 largest accidents in the hydrocarbon industry has been estimated at over $34 billion. That's a very, very significant figure to me. And each of those 100 incidents exceeded $134 million in value. And the other interesting thing is that the greater concentration of these losses were from 1999 to the present. So like I said before, we may not be seeing a greater frequency of incidents in the industry necessarily, but the incidents that we're seeing are a lot more severe. So that's very troubling. And of course, we need a better safety system, an overall health, safety, and environment philosophy to address those concerns. And one of the key ways to address those concerns is through better safety standards. And also, I think troubling to us at ARC is that so many people are still very unfamiliar with the ins and outs of the current crop of safety standards that are out there. And that includes IEC 61508, which is really kind of the umbrella safety standard for manufacturing. And then we have IEC 61511, which I'm sure you've all heard of, which is really the process automation related section of that standard. And we have ISA 84, which is the ISA standard, which is essentially the same as the IEC standards with a few exceptions. And we actually have a very good update on that standard later that we'll talk about. And this is a view of the IEC 61511/ISA 84 life cycle, which is fairly complex, and it requires a lot of engineering effort. One of the things we've seen is that end users, as I'm sure you know, are challenged and restrained or restricted in terms of the amount of qualified personnel that they have to do some of these complex tasks that are associated with safety engineering. And they're looking to some other people for help, such as the automation suppliers and systems integrators. And we'll talk about this life cycle as well. Migration, as I mentioned before, there's a lot of very old safety systems out there that need to be migrated, just as there are DCSs. A few years ago, ARC did a study, and we determined that there's $65 billion worth of process automation systems that need to be modernized in some way, and they've essentially reached the end of their useful life. I think there's lots of safety systems out there right now that need to be modernized as well. And even if you consider that safety systems are just 12% of that DCS number, you still have an $8 billion figure of systems that need to be modernized. And in that figure, I don't even think we're including things like the old relay-based systems, where I actually had one end user in the hydrocarbon industry describe to me the current state of the old relay-based systems as being brittle. Nobody even wants to touch those. And the thing is, once you do touch those old systems, according to the standard, you pretty much have to replace the whole system. So it can be kind of a daunting task because when you're replacing process control systems, you can do that piecemeal if you want to, right? You can do a phased migration and change your HMI and change your controllers in a phased manner. But you can't do that with a safety system. You have to change the whole system, and in many cases, the safety devices as well. So it's really an entire system replacement. And one other word, I'll just skip over these slides. I think we might want to talk during the panel discussion about the increasing role of devices in safety systems. One of the things we found in our research is that it's not very often that the logic solver in the safety system fails, right? If you're going to have a safety system failure, it's more likely to be one of the devices, or even more likely to be a valve, a final element that's going to fail in your system. So, we do see a need for a better view into what's happening into those SIS devices. And I think our current crop of, intelligent devices and diagnostic capabilities and so forth might give us a better window into what's happening there. I don't want to go on too much longer. The last thing I want to mention is we are here today to talk about integrated and or interfaced control systems and safety systems. And we do believe that there are many benefits that can be obtained, at least by some level of integration by these systems. And then this is our view of the various levels of integration between the safety systems. So we have interfaced, which is, there is some kind of a gateway or interface between the safety system and the basic process control system, or BPCS. We have integrated systems, which have various levels of functionality. They could share the same network, same HMI, same engineering environment, and there are advantages there in terms of reduced cost and training and so forth. And then we have sort of the more extreme end of the spectrum where it's completely common. You may have BPCS controller and a safety controller kind of in the same chassis or the same environment. But I'm not going to go into detail with that right now. I think we have some experts up here that are a lot more qualified than I am to talk about these various levels of integration and their advantages and disadvantages.